The question says in the given chemical reaction, the reactivity of different alcohols is. Reactivity of different alcohols is. You can see in the option we have primary, secondary and tertiary alcohol. Okay. And if you look at the reaction, you can see alcohol is reacting with hydrogen halide. In general, we have learned a primary alcohol is there. Removal of OH from primary alcohol is not easy because you can see OH is a poor leaving group. But once it is protonated by hydrogen halide, then in the form of water molecule, it will be removed easily. Okay, this is how this chemical reaction takes place. And if we talk about primary, secondary and tertiary alcohol, let me write the example. Let's say we have a primary alcohol, let's say CH3 is there, CH2, and then we have CH2 and OH is there. This is a primary alcohol, then secondary alcohol, CH3, CH, and then we have CH3 and it is OH, secondary alcohol. Next we have tertiary alcohol, CH3 is there. Here we have CH3 and then OH is there. This is tertiary alcohol. Okay. Now we talk about removal of OH. The alcohol which removes OH easily will be participating in the reaction very fast. Okay, the alcohol which removes OH very easily will have greater tendency to participate in the reaction, because what happens, OH and H will come, and because this is hydrogen halide. Hydrogen halides are in acidic in nature. Let's say HCl, HBr and HI. So hydrogen halide being strong acidic, having the strong acidic character, will easily remove what? H plus ion. Easily will remove H plus ion. And from here, if alcohol is having greater tendency to remove OH, H plus ion, OH plus ion will combine together, will remove in the form of water molecule and leaving behind alkyl halide. This R plus and X minus will combine, forming alkyl halide. Okay. So now pay attention carefully. Let's say if I remove this OH, so this will carry positive charge. If I remove OH, this carbon will carry positive charge, and if we remove this OH, this carbon will carry positive charge. Okay, you can see we got the carbocation, carbon having the positive charge in carbon chain, carbocation. Okay, you can see this carbon connected to only one carbon, primary carbocation. This carbon connected to two other carbon, secondary carbocation, and then we have last this carbon connected to three other carbon. This is tertiary carbocation is there. And about the stability of carbocation, we have learned a tertiary carbocation. We have the tertiary carbocation. Tertiary carbocation is more stable than secondary carbocation. Secondary carbocation is more stable than primary carbocation. So you can see, if OH is removed from primary alcohol, so we get very least stable carbocation is there. But if we remove OH from the tertiary alcohol, then we get highly stable carbocation, highly stable. So you can see tertiary alcohol, by removing OH, it is gaining stability. So it will have a greater tendency to remove OH because it is getting stabilized. Okay, because it is getting stabilized. So you can see the reactivity of tertiary alcohol will be greater than secondary alcohol, and then secondary alcohol will be more reactive than primary alcohol in terms of releasing OH minus ion. You can see this is the reactivity order is there. So tertiary, then secondary, and then primary is there. Option A is correct. If you like this video, please share and subscribe to the channel.